All right, welcome everybody. Lesson number 1, AP Calculus. This is a very difficult course, but little by little we will get through it. So the first concept within calculus that we go into are limits. What is the idea of a limit? What is the definition of a limit? For today, we're going to go through the idea. I'm going to give you the definition of a limit, but this might take some time to actually sink in. Today we're going to talk about the idea of limits. Okay, so first what I'd like you to do is just have this in your notes. This is a one-sided limit, and here this is a right-sided limit. And what does that mean? How do you read this notation over here? The way you read it is, step by step, we're going to read it together. It's saying the limit of f of x as x approaches a. Now notice how you see how there's this positive symbol here. You're going to say as x approaches a from the right is equal to L. And L is your y value. Okay? And what this means, we'll do some examples. Similarly, there's a right-sided and there's a left-sided. And how do you read this? You just say the limit of f of x as x approaches a from the left is equal to L, or to some y value, right? And notice one thing that I should write, L must be a real number. Okay? And that'll be very important very soon. Let's look at the next concept over here. We had a limit from the right, we had a limit from the left. Now this one puts it together with this definition over here. This is the limit of a function. So it's just saying the limit of f of x as x approaches a, this is going to be from the left and from the right. If the limit from the left equals the limit from the right, then the limit is stated to be defined at L. Okay, and what this means, I'm telling you, this will take a few lessons to fully get. But for now, just have this in your notes, and we're going to definitely go through it later on. Okay, for today, we're just going to go through the idea and concepts of finding a limit graphically. Now, to do this, you're going to have to kind of watch me get these limits, and then you're going to get a better feel for it as we do examples. So let's take a look at this example over here. Here we have this graph, and it says consider the graph of the function y equals f of x graphed below. So how does this graph look like? It looks like it's going like this, and then at -3, notice how it goes to positive infinity. Then at -3, it gets down to negative infinity, and it goes like this and like this. I'm like, okay, whatever. But let's actually go through the first question. What I want you to do is try and read this on your own, based on the notations that we had in the quotations, right? Here, how do you read this? Try and read it by yourself. And try and read it after me, or repeat after me. The limit of f of x as x approaches -3 from the left. What is it equal to? What is the y value equal to? So let's just take a look here. And what do I mean by that? You see, if this is -3, you could approach -3 from the left, or you could approach -3 from the right. What are the values of x left of -3? They're -4, -5, -6, -7, and so on. So it's saying as x is approaching -3, what is the y value? Or where is it going to? So let's just take a look here. What's happening at -8? When x is -8, what is the y value? It looks like it's a little bit under 3, right? What happens at -7? What's the y value? It looks like it's at 3. What's at -6? It looks like it's a little bit higher. What about at -5? Where is it approaching? It's approaching 4, right? But f of -5 is actually -3, and we'll talk about that later. But the idea to continue, as x is getting close to -4 from the left, right? Notice that we're coming from the left. What's the y value? It looks like it's a little bit above 4. But what happens at -3? Notice that as x is getting close to -3, what's happening to the y value? It's getting closer and closer to positive infinity. And that is the limit over here. But notice that we stated something very specific before, that L has to be a y value. But notice that L also must be a real number. And the question is infinity a real number? And this, let me just have this in our notes. If the limit goes to either positive infinity or negative infinity, we can also say that the limit does not exist, or we could say DNE, because by definition, L has to be a real number, and infinity and negative infinity are not real numbers. They're ideas, okay? So you see the limit goes to positive infinity as x is getting closer to -3, but we say the limit does not exist. And that's the DNE over here, okay? And like I said, we're gonna go through a lot of these practice together, okay? Now let's look at this one together. Here, what I want you to do is try and read this by yourself. Pause the video and try and read it. The limit of f of x as x approaches -5. Notice that there is no plus symbol or minus symbol. It's not coming from the right or from the left. It's asking, is it coming to the same location from both sides? So let's take a look over here. Where is -5? -5 is over here, right? Notice from the left, where is this value going to? From what y value? It looks like it's going to 4, which is correct. It's saying that, you see, notice how from the left it's getting to 4. Notice from the right, it's also coming to 4. So this limit is equal to 4. Because from the left and from the right, it's going to the same location. Notice, what is f of -5? When I actually put in -5, the value is not 4. It gets very close to 4 from the left and from the right, but what's the actual y value? It's -3. Okay? And like I said, patience. We're just going to do some examples, and little by little you will get this. Try and do C by yourself. What does C say? The limit. Pause the video and try and do this one by yourself. The limit of f of x as x approaches 4, notice that we have to check it from both sides, from the left and from the right. So notice, where is x equals 4? It's right here. So what I could do is a little this. Notice from the left, what y value is it getting close to? It looks like it's getting close to 4. I mean, it is. You see how it's approaching 4 from the left, and it's also approaching 4 from the right. So here we could just say that the limit is going to 4. Because that is the y value, it is getting closer from the left and from the right. But notice, hey, what is f of 4? When I actually plug 4 in, notice that there is a closed circle here. So it is actually 4, unlike at -5, because there's an open circle over here. And these ideas of open and closed circles, we will get better at them, okay? Let's try and do the next one. Here, letter D. Try and do this one by yourself. And read it. I want you to practice reading it out loud. Even if there's no one in the room, don't think you're a crazy person, right? Just get the habit of saying it. The limit of f of x as x approaches 2 from the right. So notice that, let's say if I have positive 2, right? Here it's saying it's coming from the right side. So notice how if I have a 2 here, I could approach 2 from the left, or I could approach 2 from the right. Notice that at 2, the graph coming from the right side is this side, because what is everything left of, what is everything right of 2? It's this graph here. If the question said what's coming from the left, then we look at this part over here. So notice from the right, what is it getting close to? It's getting close to 8. And it doesn't matter that there's an open circle over here, because I'm not saying, the question is not what is f of 2. That's not what the question is saying. It's saying what is it getting close to? It's getting close to 8 from the right. Look at this question, letter E. What is it getting close to from the left? From the left, what y value is it getting close to? 1. But hey, what is f of 2? F of 2, pause the video and try and answer it. It's 1. Because when you plug in 2, the closed circle is here. Okay? Now, let's look at this part over here. This question over here is saying, what is the limit of f of x as x approaches 2? Notice from the right, it goes to 8. From the left, it goes to 2. Now, this is where we pause and we look at our notes very quickly. Notice, for this definition of a limit, this will only be true if and only if the limit from the left has to equal the limit from the right. Okay? Does the limit from the left equal the limit from the right? In this case, no, it does not. Because on one side, it's going to 8. On the other side, on the right side, it's going to 8. On the left side, it's going to 1. So here we say the limit does not exist. Okay? But here, let's explain why. How could you explain why this limit does not exist? Okay? Pause the video and try and write it out loud or say it out loud. The limit from the, basically the limit from the right does not equal the limit from the left or vice versa. So you could just say the limit of f of x as x approaches 2 from the right does not equal the limit of f of x as x approaches 2 from the left. That's this notation here. It's saying that the limit from the right does not equal the limit from the left, so the limit does not exist. Okay? Let's try the next one. You see, these are getting fun. Don't lie. These are getting fun. Here, try and do G. Okay, H and I, these are like very confusing. So we will definitely learn more about this later. Let's skip H and I. We're not going to do H and I today. Limit of, let's do G. Here it says the limit as x approaches -1. Notice it's saying from the left and from the right. So the limit from the left has to equal the limit from the right. So let's take a look. At -1, when x is -1, notice how from the left it's going to 0. Because what is this y value? It's 0. And notice from the right, it's also going to 0. So here, this is simply 0. Okay? What happens if there was an open circle here? What happens if we put an open circle here? Does the limit still exist? Pause the video and think about it. Imagine, because here there's a closed circle. Imagine if there was an open circle. Does the limit still exist? Yes, it does. Because from the left and from the right, it's approaching the same location. It's approaching it. It doesn't mean it has to be exactly there. Okay. What I'd like you to do is try. Okay, and actually, you know what we'll do? Yeah, H and I we're gonna skip. I should not have put those because what H is saying, I'll just go over the idea. Let's read it together. It's saying the limit of f of x as x approaches -infinity. So it's saying as x is getting closer and closer to -infinity, what is happening to this graph? As you go closer and closer to -infinity, it has to do with the asymptote. You see how there's this line here? It's saying that this graph cannot cross this boundary or this line. So the limit of this, because what y value is it approaching? The y value it's approaching is 2. And if you don't fully, if you have to say, wait, pause, mister, we will do a different lesson on this where we explain this more. What about this one? Try this one on your own. As it's going to +infinity, as x is going to +infinity, what's happening to the y value? It's also going to +infinity, or the limit does not exist. Why does it not exist? Pause the video. Why does it not exist? Because infinity is not a real number, and this y value has to be a real number. Okay? What I want you to do is try and do this part of the lesson by yourself. A, B, C, D, E, F, G, H, I. H is a very, very tricky one. But what I want you to do is pause the video, try and do A to I by yourself, and then we'll continue. Okay, so let's say you did these questions. I'm going to go through this a little bit fast. Here, the limit of f of x as x approaches negative 5 from the right. So where is negative 5? From the right, it's approaching 7. When it's approaching the limit of f of x as x approaches negative 2, notice for negative 2, from the left and from the right, it's going to 4. Okay? It's just hitting that spot right here. Here, this is saying the limit of f of x as x approaches negative 3. Notice that for negative 3, from the left and from the right, it's going to 5. Even though it's an open circle, it's okay. But hey, what is f of negative 3? You see, it gets from the left and from the right, it gets close to 5. That's the limit. But what is the actual value when you plug in negative 3? It's negative 6. Okay? Good, good, good. What about here? The limit of f of x as x approaches 3 from the right. Here, as x approaches 3 from the right, oh, this was a tricky one. Here, notice from the right, does not exist. Okay, my bad. I could see it, so many of you like, okay, huh? It's not 9. Okay, it's not 9. From the left, it's 9. But from the right, notice, you see, from the right of 3, hey, what is to the right of 3? There's nothing there. There's nothing here. You see, from the right, it's not coming from anywhere. From the left, it's going to 9, but from the right, it does not exist. That was a little tricky. My bad, my bad. Okay, so we just answered E. Yeah, from the left, it's going to 9. Okay. This is saying negative 5 from the left. Where is negative 5? Negative 5 is here. Negative 5 from the left. Because you see, like, if from the left, it's going to negative 2. From the right, where is it going? From the right, it's going to 7. What about as x approaches 0? So notice 0 is here. From the left and from the right at x equals 0, it's at 6. Now this one was a little tricky. Limit of f of x as x approaches negative 9. Now, basically, you saw how I did this question, letter D. What I want you to do is pause and think about this one for letter H, and let's see if you change your answer. Hint, it's not negative 7. So from the solution, notice that the limit from the left has to equal the limit from the right. From the right, what is the value? It's negative 7. But from the left, there's nothing on the left side of it. So here, it doesn't exist. So here, this does not exist because the limit as x approaches negative 9 from the left does not equal the limit of f of x as x approaches negative 9 from the right. Oh, my bad. I just realized I didn't show this part. I'm sorry. This is 6, and this is here. Okay. Last one, let me zoom in a little bit. Whew. A 19-minute video. I didn't want it to drag this long, but hopefully this was good. It can't be too bad. We'll definitely practice, okay? Last one, limit of f of x as x approaches 4 from the right. Notice from the right of 4, it's going to positive infinity, or does not exist, because this y value has to be a real number and positive infinity is not a real number. Okay, we're done for this lesson here. What I'd like you to do is try and do this page on your own, and what I'll do is I'm going to post the answers in the Google Classroom, or maybe I'll make another video of going through this. Okay, so try and do this on your own. This we'll talk about in the next lesson. It's not too bad. And if you can, and if you're having fun with it, try and go through the homework of homework 1, 2. Here it's just practice. And what I'm going to do is I'm going to make another video going through this stuff. But try and do it on your own. Okay, Smiles and happy faces. You just did your first lesson of AP Calc. Yeah, good job. I'll see you in class.